Welcome. So we are going to talk about data motion control solutions. Okay, today's topic. So it will take around 2 hours. We will be together. So first of all, we will talk about what solutions we have, and then I prepared some demo kits for you. So we will make some hands-on. So you will see how does it implementing with AX8. Let's get started. Yes. Today, first of all, we will talk about 15 and 50 MC highlights and product ordering information, and also competitive landscape, verticals and potential applications. And we will also some reminder to things them in mind. Okay. And then we will focus on also CODESYS. Okay, let's have a look to data motion control solutions. Right now, what are the solutions we have? If you are familiar, DVP, AS, and AH also are PLC families, and those families also has a motion controller in their family member. Okay, we have a DVP motion solution, AS, AH, and now we have a CODESYS-based motion solution, and it's called AX. You can see the highlights over here. So for the AH, for instance, AH hot swappable and redundancy. For AS, multifunction modularized easy installation. And DVP high performance, cost effective, and AX flexibility and scalability. So if you see on the chart, first DVP MC series, we can talk about that it can meet most of the requirements from the low-end applications. And then we have AH EMC, which can cover many applications between low-end and middle-end. And we have AX8, which is Ethercat-based CODESYS motion controller. As you see, it covers most of the area between middle-end to high-end applications. Okay, and hopefully in Q4 or I guess beginning of new year, let's say, we will have AS500, two model, one of them for Ethercat and the other one for CANopen, like DVP. Okay, I can simply say that DVP MC and AS500 have the same motion functionality, identical same, only the PLC part is different. Okay. And also in the beginning of new year, hopefully, AX3 will be released, which is also CODESYS based and Ethercat communication. So this is our roadmap for now. Okay, let's see the portfolio. So we say that two main control bus we have, Ethercat and CANopen. And over here in this page, you see the motion control bus, Ethercat control bus, and we have DVP AS516, EMC, AX308, and AX8. Okay, depends on the number of axes. It is the first separation. Here you can see AS516 supports up to 16 axes. AX308 will support up to 8. AX8 there are 3 submodels which support 16, 32, 64. Okay, so all of them can work as a single axis motion for sure. And ECAM supported by all, and rotary card is also same, supported by all. G-code only DVP 50 MC and AS500 series support G-code. EMC and AX3 will not support. AX8, if you would like to use the G-code or CNC, you need to get additional license. Then yes, it is possible to use G-code, CNC, even robotics. Okay. Yes, this is important. Third-party Ethercat devices. Why it's important? Actually, for this series, for sure it is yes. But for DVP and AS, so far it is not possible. It only communicates with Delta servo. Okay, and encoder interfaces. DVP 50 MC has 2 incremental and 1 SSI. AS5 is the same. EMC has 2 incremental interface for encoder. AX3 has incremental 2 and SSI 1, and AX is 1. Okay, and other communication protocol. DVP and AS supports Modbus, CANopen for sure, and Ethernet IP. And EMC, same Modbus, can open Ethernet type, and in addition, DeviceNet, Profibus, BACnet. AX300 supports Modbus Ethernet IP, in addition, OPC-UA, like AX8. And software environment. So for 50MC and AS500, we can use ISPsoft or CanOpen Builder. Both are possible. AHEMC is ISPsoft only, and AX300 and AX8 CODESYS based solution can be used CODESYS development program environment, or we will release new software, the DIA Designer AX, which is based on CODESYS development, but there are some useful tools for Delta users. Okay, but right now the DIA Designer not released yet, so we will go through CODESYS platform today. Okay, we talk about the portfolio and have a look to DVP MC series first. We say that there are two different models, depends on the communication network. So CanOpen and EtherCAT, and each has different sub models, depends on the axis, servo axis. So 15MC is 24 axis, dash 06 up to 6 axis support, and same for the EtherCAT model, okay, and can be programmed by ISPsoft or CanOpen Builder. Both can be used to program. So it was over. Let's see DVP15MC. So at the bottom, you can see there is a CanOpen port for motion, and there is a SSI port and Modbus communication port, okay, and there is a port for incremental encoder. There are two Ethernet ports which supports Modbus for sure, and there is integrated I/O port. And in this I/O port, there are 16 digital inputs and 8 digital outputs. And there is one additional CAN open port, but this is not for motion. This is standard DS301 port. So for the conventional master-slave communication. So this is the overview for 15MC. How about 50MC? More or less same, we can say, but for sure there is a EtherCAT port for motion, and there is a serial communication port. There is a incremental encoder port, and yeah, CanOpen ports are, there are two CanOpen ports, but both standard DS301, not for motion, and integrated I/O port like 15MC, and there is one Ethernet port for Modbus, for instance. And this is the overview for DVP 50MC. Okay, DVP 50 and 50MC both support DVP modules. Okay, so you can yeah, there is a built-in I/O, but not enough for sure for some applications. So you can extend them with DVP modules. And maximum 480 digital input output, or maximum 8 spatial modules. And also DVP motion controllers like DVP series PLC supports left side expansion as well, up to 8. Okay. What is next? We says that depends on the version. It can support up to 6 or 24 axis, and both can support up to 8 additional virtual axis. Support encoder axis, support PLC open function blocks, and for single axis motion you can control the position, speed, torque, and homing commands. For the multi-axis you can use ECAM function blocks, rotary card applications, and coordinated movements. And for G-code you can use linear, circular, and helical interpolation. This is the more or less topology for 15 and 50MC. It goes through the servo drives, CanOpen or EtherCAT. So we have two different models. So you will also, on Thursday, I guess, you will see details about the servo drives. And on the upper layer, for the control layer, yeah, you can communicate via Modbus TCP. with the HMI or for programming or for the another PLC. So this is the more or less topology. Okay, for the field devices, CANopen or EtherCAT. For the upper layer, Ethernet-based communication. And on the other hand, so you can also get some feedback from the VFD, or you can get some feedback from the encoder. And we said that there is a standard CANopen port. With this CANopen port, you can communicate with VFD or other servo devices. Okay, so it was the EVP series motion control solution. And we said that, okay, we launch a partnership with CODESYS, and we release CODESYS-based motion controller, which is called AX series. Let's have a look at AX series. First one is the AX8. It is a PC-based motion controller indeed, and these motion controllers have a powerful industrial PC platform. Is there a question? No, okay. If you have any question, please let me know. Okay, so yes, this PC-based motion controller has Windows 10 IoT inside as a operating system. And yes, and it is EtherCAT based. Okay, and as I said, you can also use AX8 for robotics or CNC, but needs additional license. How about highlights? So for sure, it's a PC, so there is a powerful processor, and HDMI port to monitor the Windows side. So there is a interfaces like 2 Ethernet port, 4 USB port, 1 SD card slot on the controller, and there is a EtherCAT port. Okay, and there is a integrated I/O point. So here you can see that 8 phase digital inputs, output, encoder, interface, SSI, even serial RS485 communication supported. Okay, so also you can use these 2 Ethernet ports for Modbus TCP or Ethernet IP, even OPC UA. And how about the Windows part? So there is a standard operating system, Windows 10 IoT, and works with CODESYS in the same device. But CODESYS does not work on Windows, so they have the different core inside, so they work separately. Yes, industrial PC with Windows 10 IoT we set, and it supports incremental encoder interface, serial ports there are, and also it supports EtherCAT, Modbus, OPC-UA, and Ethernet IP. So for the EtherCAT, we use this button. This one for EtherCAT, this two is the standard Ethernet port, and this is the HDMI port. And this Ethernet port supports Modbus TCP or Ethernet IP or OPC UA. Yes, we have 3 different sub-versions which supports up to 16 or 32 or 64 axis. So it depends on your application. You can get one of them. And has CODESYS soft motion inside. And we have another license, which is CODESYS soft motion with CNC and robotics. Okay, and also there is a on the Windows part there is a Delta Soft HMI. So normally for the applications, what we are doing, we have a hardware, PLC or any controller, and we have a HMI. So, but this is PC already, and we have a software inside of this PC. So you don't need to get additional hardware for HMI. So you can run directly HMI project inside this soft HMI and mount, connect the monitor to the PC via HDMI port. And yes, you can control the controller with the soft HMI. One platform for all motion control applications, because there is a soft PLC and soft motion inside, and with additional license there is a soft motion CNC and robotic license as well. And it supports for sure IEC 61131-3 and which PLC open standards and eCAMs. So this is the advantage of the soft motion. You can directly use motion blocks defined by IEC 61131. And for the advanced motion, with the additional license, you can use CNC and robotic applications like G-code or kinematic transformations for robotic. And these are all in one controller. So it is the biggest advantage indeed. Here you can see that libraries for robotics applications, for instance. What are the advantages? Yes, so for the software automation engineering tools, we use CODESYS. So CODESYS is one of the biggest platform, we can say that, which is used in the industrial applications. So yeah, there are many users, so it is quite easy, quite simple to debug. And if there is any error, then there are many users as well. So it is the advantage that it's already discovered and solved most of the time. And there is a powerful processor inside because it is PC based, and yes, Windows operating system, 10 IoT inside, and supports different communication protocols. So it extends the integration with the third-party devices, especially. And yes, PLC, motion, HMI, PC, all in one device. So it means that cost reduction for the applications. Yes, it is how it looks like. So, and this is the communication topology, we can say. For the field devices, we use Ethercat. And via Ethercat, we can communicate with the servo, with VFD, or any third-party devices, remote I/O, input-output modules. And after controller execute them, shared with the higher layer with Modbus TCP or Ethernet IP or OPC-UA. And yeah, also robot is possible to control with the AX8. And AX300, we already mentioned that it is coming soon. Most probably beginning of the new year, 2021, we will release this model. What is the biggest differences between AX8? If you remember, AX8 supports minimum 16 axes. So can be that maybe you don't need 16 axes. If you have smaller applications, then AX300 will fit there because AX300 supports up to 8 Ethercat servo drives. Okay. Yeah, communication interfaces. Let's have a look again. For the AX300, we have an encoder interface. We have Modbus serial communication port. We have Ethercat master port up to 8 axes. We have integrated I/O port. And we have 2 Ethernet port. One can be, for instance, for programming, and the other one for HMI communication, whatever. The biggest advantage of the AX300 is that it supports AS modules, option modules. Okay, so here you can see, for instance, analog modules. So you can mount AS modules. You can use AS modules with AX300. For the AX300, you have to, sorry, for the AX8, you have to use remote I/O solution. But for AX300, you can use AS modules like shown here, AS04 analog output or temperature controller or whatever. Yeah, there is an integrated high-speed digital input and output. Incremental and SSI encoder are supported, and there is serial port for Modbus communication, for instance. There is a Ethercat, Modbus TCP, OPC-UA, and Ethernet IP communication on AX300. We said that it supports up to 8 axes, and there is a CODESYS soft motion inside, so you can use again motion blocks defined by IEC 61131. So same topology like AX8. Here with the field devices communicate via Ethercat, and then with the upper layer communicate via Modbus, Ethernet IP, or PCUA. Okay, we says that today we are gonna focus on AX8, and for AX8 we use CODESYS development environment. So today we are gonna talk about this environment together. So this is the overview of the interface. If we look shortly, on the left hand side there is a project management tree, and at the bottom there is a hardware configuration tool, and in the middle there is a development tool, the place that we write our own code. And here for sure there are some quick icons and the menu over there. We can jump to the hands-on part. So we'll have a look to interface first, get familiar, and yeah, connect with the real devices. Yeah, if you like, let me share my setup first, what we have with us today. So here, yeah, I guess you can see my video right now. So here there is a AX8 controller. There are three servo accesses, ASTA A2E Ethercat. And yeah, there are three axes, as you can see over here. Okay, these are all free right now. So here we mentioned that there are two Ethernet ports and one Ethercat port, and this is the input-output port, and 24-volt power supply over here. So for the connection, we use this one, and for the Ethercat communication, the green one is going there, and then from one to another. So this is the setup we have for today. Let me turn back my screen. So this is the CODESYS environment. So how to get this CODESYS development environment? It is free. So you can get from the CODESYS download, or you can download from our download center as well. So here it is our download center. In our download center, if you choose the industrial automation and the CODESYS motion solution and software, then you will see that there are some packages over here. So here, see, depends on your operating system. You can download CODESYS development system, or as I said, it is just regular CODESYS development environment. It is free, so you can get from CODESYS website as well. So here, after download and install this development environment, so this is a modular software, we can say. So you need to install which program or which hardware you would like to program. So for instance, right now we want to program AX8, so you have to install AX8 package in the software part, development part. Otherwise, you cannot see. So you have to download also this package and install in the CODESYS development environment. So yeah, when you open the CODESYS development environment, this is the interface. So from file, you can create a new one. Here, asking you the name and the location to save the project. But I want to show you this part here. This is the place you choose which device you would like to program. So at the beginning, when you install, you will not see AX8 over here. You'll just see CODESYS controller inside. To test the CODESYS environment, you can use them, no problem. But if you would like to connect to Delta hardware, then you need the driver as shown here. So how to install this driver? Let me cancel this one. So after install the CODESYS environment, you need to go to Tools and Package Manager. Okay. So here I already installed. So here you can see that it is installed and 1.000. So if you check from the website, so it is the latest one right now. So you need to come Package Manager and install it. So it was the controller. It was for controller. And for Ethercat, for motion, we will use ASTA A2E, right? So for the ASTA A2E, we also need to install slave devices. So again, you need to come Tools, but this time device library. And here, you need to install the ASTA A2E. I already installed, so I guess I can show it here. Actually, I can also. Slave. Yeah. Here you can see I installed A3E, A3E, yeah, A2E. I already installed them, so I don't need to do it. But in order to reach slave devices, the target slave devices, you need to install it first. So after you install package manager, device repository, etc., then you are ready to program Delta hardware as well. So you need to go File and New Project. And here there are options, empty HMI standard. So if you choose empty, it is totally empty. So you need to create also the necessary files by yourself. If you are not an advanced user, then I suggest you to go through standard project and give a specific name like training and asking you which device you would like to use and which language you would like to program. So yeah, let's keep it structured. We can change it. So when I clicked OK, and CODESYS environment create the project for me, and on the left-hand side we will see all the necessary files. Here you can see still not ready. We think. Yeah. Okay, so here we are seeing the device. So this is the PLC part, okay, and this is the Ethernet communication and build-in I/O part. First, we said that it's good to show how to connect. So we need to go device, okay, and here when we go to the device, here inside the communication setting, in the device there are many settings, but first we need to set the communication path. So here inside the communication settings, you can type the name of the PC directly or IP address if you know. If you don't know, you can scan the network. Okay. There is one thing is that we say that this is Windows, right? Windows-based motion controller. So also there is a default IP address, but you can also go to the Windows part to check what you have inside. So as you remember, there is a HDMI port on it, so you can mount a monitor to see the Windows part as well. But it's also possible to monitor them with the remote desktop on the Windows. So right now, my PC and the AX8 are connected with the Ethernet cable. So here, I need to type the IP address of the AX8. So this is the default IP address. Okay, so when I type the IP address of the PC and then connect, okay, it's connecting. Yeah, and password is default 0. Yeah, asking for the certification, yes. Yes. So hopefully you can see that this is the Windows part of the AX8. So we said that it is Windows, right? So here you can see Windows part of the AX8. There is a one software, it's open. What is this software? This is the one we mentioned. This is called Soft HMI. So when you develop a project with DOP soft, you will see tomorrow, HMI project. So instead of downloading the DOP 100, when you download the soft HMI, so you can control directly the controller from this window page, okay? So for now, yes, this is important. So let me show you Ethernet interfaces. So we say that there are 3 actually Internet interfaces. One of them for Ethernet and the other 2 is for The other two is for regular Ethernet. So here you can see that two of them is the connected. One of them for Ethernet over here you can see, and the other one for programming. And the IP address is 0.10. It is the default IP address, as I mentioned. So you can change the IP address of the AX8 over here. I guess we have a question. Can soft HMI software be used on any Windows-based PC as well? No, this is for specifically AX8, not any Windows operating system. Yeah. Thank you for your question. Yeah, soft HMI is only belongs to AX8, so cannot use with any other industrial PC. For now, let's say. Okay, so this is the IP address setting. So you can change the IP address of the AX8 over here. But please keep in mind that it will not affect, because there is one software inside the AX8 to protect your user project or also Windows settings from the end user. Is that when this software is enabled, any change you make will not affect. So right now it is enabled. Okay, so when I change something on the Windows side, when I restart the PC, then it will turn back to the default settings. I mean the settings before I did. So if you want to change any settings on Windows side, first you have to disable it. But don't forget to enable it back. As I said, it is for you as well, because when you ship the machine to the end customer, you will not sure that what are they gonna do in the Windows part. So it is good to protect settings on the Windows part. Okay, so this is already in desktop, so you will recognize it. So yeah, if you make any change, it will not affect. So keep in mind that this tool is disabling it. Okay, so we talk about the IP address, and also here there is a CODESYS soft motion tray, and when I right click here and go to the PLC configuration, here you can see the status of the configuration. I mean the target name, IP address, and the status right now, and application. There is one application inside and it is in stop mode right now. There is no system error. So you can see the runtime of the CODESYS. There is another setting, is that on startup. So start PLC with the basic system service and start real-time basic system service when booting. So if it is not enabled, when you boot the PC AX8, the project, I mean the control will not run immediately. It starts on stop mode. So you have to come over here and you have to make it run by yourself. But if you enable this, so each time when you reboot it, it will start on. So please also keep in mind that if you want to run PLC in each power cycle, then you have to enable it. Actually, it is default enabled. Okay, so this is the interface to get some information about the CODESYS runtime. So here what we are talking about, so there are two types, CODESYS development environment and runtime. Development environment is the part that we write our code, and the runtime is the kind of the root of the PLC, so it is executing your program inside. Okay, so this is the Windows part. So actually you don't need to do any setting over there. So for motion, you can just simply start to use. So I will just close this one. We don't need that one anymore. So we know IP address anymore. So we can type direct over here, or we can scan the network and see the environment already find the runtime, CODESYS runtime. And also you can see the module and the other version, etc., other information. And when I clicked OK, so you will see that this will become green as well. So it means that, okay, the software, development environment and runtime environment are matched. And now it is possible to connect directly. So how we reach over there? So here, double click to device. and then communication settings. So in order to download a PLC project or upload or just go online, you need to set communication setting first. Okay, so this is all. And application is the part that actually we wrote code, okay, and it is called application on the CODESYS side. So this is the place that we see which application running inside the controller. So I will not go deep because these are advanced settings, but I just want to show log function. So log function is the area that PLC stored what actions has been done and what are the errors before. So here when I click to refresh, I guess, yeah, here you can see all the information, exception, error, warning, all the logs inside the controller. Okay, maybe in the future when you use, if you have some struggling or if there is any issue, you can check over here if there is any error or not. Or sometimes we can ask you to provide us the log file. So this is the part you are gonna provide us. So you need to go at device and then log. And see here written connected because this log file comes from directly from the runtime. Okay, so here you need to export it, export the display entries to XML. So you need to export them and send to us for debugging. So this is important. I would like to show, and yeah, rest is advanced settings. No need for now. This is the communication settings we show. Okay, let me come back here. What we have. Physical I/O. So we say that there is a physical input and output on the AX8. So we can also use them. But how to match the physical input and the software input? So here there is a on the button there is a local digital input and output section. Let me go there again. The software. Second, yeah. Here there is a built-in digital input and output. So here you can see there are 8 digital input and 8 digital output. So yeah, right now we are not online, so not showing, but here is the place we are gonna match the physical input. Address is X 0.0, 0.1, and the output is Y01. Actually, for data, we called as Y channel as output, but in the CODESYS part, it's called Q. But you don't need to keep the address in your mind. You just simply make mapping over here. And then after you set the mapping, you don't need to remember the address. You just need to keep only the variable name. For instance, output, yeah, let's call my output 1. Okay, so it is variable-based controller. So once you need to finish your assignment, variable assignment, then in the project you will use those variables, not the outputs. Physical address, I mean. And it is same for the input as well, and same for the encoder too. So here is the part we enable. And after you complete those settings, what you need to do, simply you need to go login. Okay, so online and login. When you click the login, asking you that, okay, there is an application, would you like to download? And I click yes. So it is compiling. You can see that generating code and software environment, development environment, checking if there is an error. So if there is no error, then it is downloading to the CPU and going online. So here you can see the status right now, program loaded, and no change, any change on the program, and it is stop mode right now. So here you can control the status of the controller, stop on run. Okay, so what we did, we just simply go to the online and login. When you click the login, it compile first, then download to the CPU, and then go to the online. or you can simply go to the download to do it manually. Okay, so we also mentioned about this part, and let's talk about also the programming part. So for the programming part, we will not focus on that much, the CODESYS part, but yeah, let's have a look. So here there is a program. When we create the project, it comes as default and it is empty here. So this is ST right now. Okay, so the upper part is the place that we define our variables, and the lower part is the area that we write our own code. For instance, yeah, integer I. So we have integer I, for instance, right? So then here we say that, okay, I is equal 3. First, you need to define the variable, and then you can use inside the program. If you don't define variable, then when you compile it, will give an error that, okay, you define a I, but we don't know what is I. And also here you can see 3 error and 13 warning. So here you can see inside the precompile identifier I not defined. So here, of course, this helps you to declare a variable. So when I click declare variable, okay, says that most probably you define 3, so most probably it is integer, he says already, so it is smart. And if there is a first initial value, like, okay, when I restart the PLC, it is 5 at the beginning, but then I will change. Then you can define a first value. If there is a physical address, you can assign over here as well. You can define a comment, or yeah, you can make it retain or constant value, cannot change, or persistent. So yeah, this is the setting to auto declare. So let's click this one. So over here you can see that, okay, there is a variable, data type is integer, and the first value is 5. Then inside the PLC we change to 3. So let me compile again, and no error. So the part that we declare the variables can be like this text, or can be as table too. So depends on you. So you can use like this as well. So second, and in data type you can change like Word. So yeah, depends on your habit indeed. So yeah, you can use like this text area or table area. So yeah, first you need to assign the variables, and then you can use inside the project we said. Okay, it's good. But let's create another PLC program. How to add another PLC program? The things you see over here, it's called object. So right click to application, add object. Here you can see there are many objects belongs to CODESYS. So here there is a CNC program and settings, cam table for eCam functionalities, global variable. So you need to store on our phone. So you need to add your tool inside your project, depends on your requirement. So this is, for instance, Ethernet IP communication interface for object-oriented programming. Yeah, this is for OPC UA. So there are many tools, apps that you can use. So for another program, we need to create POU. POU is termination, comes from IEC 61131. It is program organization unit and consists of program, function block, and function. So there are 3 different type of program units. So let's create a program, but you can also create function block or function. As I said, these are more related to PLC programming, so I'm not going deep over here. I just want to skip this part quickly to jump to the motion, but still it is important to know some terminologies. So here it is the program, and give a specific name like starter, and this program, and the language is, let's call ladder, and add. So here you can see there are two programs inside this project. You can create a folder and assign to that just for easy debugging. Yeah, there are many possibilities. So what I'm gonna show you, see, depends on the programming language. Also the icon is changing. So for this is SD. So here it seems like SD, and this is seems like leather. So you can also understand which language is used inside this program. So yeah, you can use different languages for different program. So for one application, maybe it is used to leather. So some part of the machine can be written in ladder diagram, and some part of the machine can be written in the structure text. So, and here after create to ladder, you will see variable part is the same. Variable part is same like SD, but the programming part is different. So for the ladder programming, there is a toolbox here on the right hand side. So if you enable this, you will, yeah, it will show like this. So here you can see ready to use functions, instructions. Okay, also the function blocks here. Ladder elements over here. Yeah, contact. So for instance, contact, you get it here and then put another coil at the end. Okay, so define a name, my button, for instance. So this variable is just created by me and not defined in the variable list. So asking me that you want to create a variable. Yes, and it is Boolean, that's true. No need to initialization, etc. So when I click, so it comes over here. Simply you can create a variable name first, or during the programming also you can create. So my out, let's say, and it's also bool. My out. See, for this time didn't ask because my out is already defined. On the right hand side, you can see the tools in order to use inside the ladder. Okay, so here there is a box, for instance, for the let's put here and then call it move, for instance. Yeah, if you don't remember the function block name, what you can do, delete this one. For instance, insert box, and here you can search move. So when I click, it already brings it here. So here is the input, here is the output. So what I did, let me show it again. I said that, okay, insert box, okay. And here you can, if you know the path of the function, then you can go through. Let me open this one. So yeah, man, MC Touch Pro, whatever. So here I called again move. Or yeah, you can see when you choose the another one, you can also see the documentation, or you can also go to help page of the CODESYS. So when you choose the instruction and then click to F1, it takes you to the CODESYS help page. These are actually more related to CODESYS. So there are many sources on web. So for those kind of things, you can check directly from the CODESYS website or help page as well. So when I click to F1, it opened the CODESYS help page and explaining you here that, okay, a move, explanation, and an example over here, how to use, etc. So you can see the other explanations as well. So this is the online help page for CODESYS. So for the function block usage, you can also check this page. So yeah, so we created two program, and if you join the PLC training, we says that, okay, there are different programs, but the execution time can be different. So it's also same for the CODESYS. So you can define the execution time for each program separately. So it's called task configuration. Okay, so here inside the task configuration, you define which program when needs to be executed. So for now, for instance, there are 2 tasks. You can create more than 1 task. Let's see the differences, for instance. So this is the main task, and the task priority is 1. The highest one is the 0. And this is the itercat task. So it is in the same priority, but the time is different. So this task execute in 20 milliseconds and this 4 milliseconds. So yeah, the programs under the main task executed in 20 milliseconds, in each 20 millisecond, and itercat task in each one executed in 4 milliseconds. Okay, so this is the main differences. So you can create more than one and define different programs in it. So it is not freewheeling. So let's say that you have a program which take only 1 millisecond to execute. Yeah, let's say the PLC program, and the execution time for PLC program is 1 millisecond, let's say. And you said that 20 millisecond execution time. So it means that it starts to execute after 1 millisecond. Okay, program is done. Waiting rest of 19 milliseconds. I mean, when it's waiting, doing the other stuff like communication, like checking the I/O, etc. But do not start immediately to do PLC program again. No, waiting another 90 minutes, and then after reach the 20 milliseconds, again execute this program. So yeah, it is time cyclic. So if you would like to execute immediately, if you would like to start immediately, then you have to choose freewheeling. So this is the main differences. Here you can see. So here, for this example, for instance, we have 2 different tasks. So yeah, for me 20 milliseconds, it's okay. So I don't use the 4 millisecond itercat task. So that's why I'm just simply deleting this and using main task and the task configuration only. Okay, so this is the part you assign. So for instance, right now we have a main task which execute in each 20 millisecond, and also PLC program is assigned. So it means that starter not executed because it is not assigned in the cyclic task configuration. So we need to call it. So you can go to add call, or you can simply drag and drop. So starter will also execute in each 20 milliseconds. So this is also execution order. So first PLC execute the PLC program and then starter. So you can also change the position. So PLC will execute starter first and then PLC program. Yes, so this is the task configuration. So not enough to create the PLC program. You also need to define when it has to execute it. Any question? If there is any question, please let me know, or any comment, feel free. Otherwise, yeah, I will keep going. Okay, this is, as I said, more or less related to PLC programming part. So I'm not gonna focus on that much over here. What I want to show is that how to connect with servo axis, because here we want to control as a motion axis, right? So so here I will demonstrate how to connect with the ASTA A2E and how to program them and etc. So right now it seems like there is an error. Let's build it and let's see what is the error. Yeah, here it is not defined. Most probably it is the reason. Yeah, expression. Yeah, this is no need. Just delete this one and execute it. Rebuild it again. Okay, so no error. So okay, in this part, I will show you how to connect with servo devices. So we said that we use itercat, and here when we create the project, CODESYS already bring the itercat master as well. So double click, and here you can see that it is already defined as a network name as well. So when I click the browse, you can see the ports, available ports can support itercat. So we use itercat. So it's already defined here. What else we have? Ethercat IO mapping. It use bus cycle task. It's also for Ethercat. There is also a task. I mean, when you need to change the data between the slave and the master. So it's also called task. So that's why there were two different tasks for Ethercat or the for main task. For me, 20 milliseconds is fine. So I just choose main task and there is no error. So simply what we need to do, right click and add the device. When we click add device, here you can add the third-party devices or Delta devices, any Ethercat slave devices. So you can do it manually, or you can right-click and scan for devices. Yeah, when you scan the devices, it goes through the Ethercat network and bring all the available devices. So I already installed the ESI files for the Ethercat, so it's already founded and defined that Delta ASTA A2E. So also the Ethercat node address is fine. So I just copy to project. Yeah, when I copy to project, okay, I click only one, so that's why it bring only one. So if you choose one, then it just bring one of them. Okay, here you can see there are 3 servo drive, and in our application there are 3 as well. So here, after we call the slave devices, this one was the master, we checked already, and this is ASTA A2E, and as a sub folder there is a axis setting. So second Ethercat slave and axis, slave and axis. So as you see, slave devices and the axis devices has different settings over here. Let's have a look what we have inside the slave devices, Ethercat slave devices. So this is the settings that we complete the Ethercat, but this is Delta controller and Delta servo drive, so no need additional setting. It's already enabled the distributed clock setting for Ethercat, and already PDO is okay. Startup parameters defined. What is the startup parameters? Startup parameters is the parameters you would like to write inside the drive when you are rebooting the PLC. For instance, let me click to add button. Here you can see all the parameters inside the ASTA servo drive. So for instance, if you want to change any drive parameters at the startup only, then you can use this page. Homing setting, for instance. Let me check over here. Where is the homing? Home offset. Mode of operation. Yeah, homing method. Yeah, this is a setting needs to be done only once at the beginning. So you don't need to change it cyclically, right? So you don't need to communicate it always and change. No, you just define homing method once and that's all. So that's okay to do it at the beginning when it is booting. So here you are adding the homing method and the value 35, for instance. There are some homing methods on servo. So you will see on Thursday. So you just define the homing method at the beginning, and that's all. So this is the page. We adjust the parameters once only. So you know, for the Ethercat, there are 2 types of communication: periodically changing and acyclic communication. So I mean, it depends on the condition. So for those kind of settings, the one that you don't need to change cyclically, you just need to define one, then you can use the startup parameters. Okay, IO mapping, no need to change because you can control manually, like control or target position, but we will use as a motion control. So we will use motion function blocks. So you don't need to, you shouldn't assign any variable over here. Otherwise, you cannot use inside axis. So don't change them. And yes, Ethercat IEC objects, status, and information. So this is just a typical Ethercat slave devices, not the axis setting. For the axis setting, you need to come over here. So here, inside the axis setting, here inside the general, you define the axis type and the limits. So this page is for just general limits. For velocity, for acceleration, deceleration, the type of the controlling. Yeah, if there is any limit you would like to define. For me, it is just a circular movement for each axis, so I don't need to define anything. And scaling mapping is the area that we complete our conversion rate between the servo drive and the user project. So for instance, we have a servo axis ASTA A2E, and the resolution is 1,280,000. So this is the resolution of the servo. And it means that for one turn, we need to send this pulse to servo, okay? So this is the resolution of the encoder, let's say, for input. So, but if you would like to turn it one, then you need to send this value to the servo. If you need to turn it double, then double of this value. So it is not simple and user-friendly to keep this value in mind and always calculate, okay, for instance, you would like to turn it just 45 degree, then okay, I need to send 4 divided of these, etc. So not user-friendly. So that's why there is a conversion here. So asking you that, okay, this is the increment, and it means one more turn. That's true. And if there is a G ratio, it can be turntable, for instance, and one more turn, maybe you have a motor and turntable at the top. So when your motor turns 3 times, your turntable turns 5 times. Then this is the area that you need to define. Okay. But right now I don't have any G ratio, so I just set 1. And gear output turns. So as the output of this conversion, yes, I have 1. And in my application, 1 motor turn will equal to, depends on me, depends on my application. If you are moving like a linear, and if you would like to use as a centimeter or millimeter, yeah, you can define over here. Or maybe you want to work as a degree, okay? So right now I can work as a degree. So yeah, 1 turn is 360 degree. And then it means that the resolution for me is 1 degree. But let's say that I want to make the resolution higher. I mean, I don't want to go to the 1 degree. I just want to go to 0.1 degree. Then what I need to do is use 3600 resolution. So it means that it is 1 turn. Okay. So if I want to move 0.1 degree only, then I set 1, then it will go 0.1 degree only. So I increase the resolution over here. But depends on application. So as I said, if you would like to use centimeter, and if you have a workload around 100 centimeter, then you can also type here 100 centimeters. So it means that in 1 turn of the motor, it goes from beginning to the end. So right now I will work as 3600. So my resolution is 0.1 degree turn. Yeah. So this is the part that we convert from servo to user interface, to user project. Conversioning, no need. So this is again a cycle task. So use parent bus cycle settings means that get the setting from directly to the slave. So it's fine for us, and yeah, and status information, etc. So same for the rest. So you need to complete all the axis setting first. But over here you can see there is a unique name. There is a unique name. Wait a second. Let's see. Yes. Thank you, Vladimir. Yes, we miss 10. It should be 1,280,000. Yeah. Okay. Yes, true. This is the resolution of the servo. And for the rest, we can use the same conversion. So this is the increment number for servo. It's defined in factory, so you cannot change it. And unit in application, I again want to use 3600. And same here. Yeah, 40. Okay. So this is something that you need to complete before work. Okay, so here you can see there is a unique name for each axis. But it is not easy to remember and it's quite long. So I suggest you to rename. So over here, you can rename the axis name. Like let's call axis 1. And there is a pop-up page says that, okay, you make a name change, but this name used somewhere in the project. You also want to change them as well. So it is quite smart. So you don't need to tracking all the variables where you used before. So CODESYS do it for you. So I just say that, okay, change in everywhere. And same for this one as well. Axis 2. And axis 3. Okay, so yes, we define our slave devices, we define our axis, and we completed settings as well. So it is done. So right now we have to compile first and then download the project, download the controller if there is any error or not. Okay, I compile it and it seems no error, so I click login. And yes, difference I know in controller. So let's download it. So here it is downloading. You can see the percentage. And when download is completed, you can see it is in stop mode right now. So I set it run. Here, when I go to online, you can see there are green icon. So means it is okay. But this one means that checking right now. So, and it is completed and these are all green. It means that, okay, your setting seems fine. Okay, so yeah, this is the way to adjust axis settings. If there are any other third-party Ethercat slave, then it is same. It should be somewhere here. And yeah, you need to assign the PDO mapping, etc. So I will focus on axis setting today. Okay, let's use inside the program. We define the axis and let's use them. So just to make it simple, I will add another program, POU, which has a programming language CFC. Okay, let's use CFC and the name, yeah, state POU. Okay, whatever. Or we can change it. Let's call it motion. Okay, again asking that you change it. Yes. Yes, I create a motion program, but again, don't forget that it is not inside the task configuration. So it means that it will not execute it. So I need to assign it to the task. Here now, PLC execute this task as well. And these two no need because there is nothing there. So we have only one task will be executed. So first for the axis, we have to enable servo, right? So for the enabling servo, we use MC power function block. How to use function block? Here again, inside toolbox, there is a box. So get the box and put somewhere. It's a free space, CFC language. So here you are typing MC power. Yes, okay, I created MC power. This is how it looks like. And also there is a name over here. It is same principle. It is a function block. Okay, we use, but we have to define a unique name. So automatically CODESYS assign MC power 0, but I will change to 1 because our axis name start with 1, 2, 3. So I will use the same principle. So here, okay, says that this is the MC power and this is the type. Like we discussed before, you had to define the variable first. So this is variable and the type is like integer, bool, whatever. This time it is MC power. So I click OK, and here you can see it is defined. So yeah, this is how it looks like. If you don't know, or if you couldn't remember the name of the function block, then what you can do, here you can click input assistant and you can search. If you know some keywords, you can search, or you can go through inside the function blocks and SM3 basic, I believe, inside this one, and POU additional, inside this folder. So here you can see helpful function blocks, see MC power, and also written that controlling the power stage. Okay, so you can also control, you can also bring it there. So I click OK, MC power, and the name is 2. Yes. And for the third one, I will go through this, so because this is simpler. So, and 3, we will create it, right? Because we have 3 axes. Okay, so these are the function blocks for enabling the power. And we don't know how to work MC power. So what we need to do, this is, as I said, defined by IEC 61131. So you can search on Google, or you can simply click F1. So it goes CODESYS online help again. And here explaining you how to use. So this is axis, reference to axis. So I need to assign the axis, which axis I would like to power on. And then enable the execution of the function block. So this enable for function block only. And this Boolean input for power stage. And this one for disable the quick stop mechanism. And here also an explanation of the output. So yeah, if you don't know how to use, or you forget, not possible to remember everything in your mind, so just go to help and check. Okay, so here is the axis. So I click to axis over here and then type the name of the axis. So let's start with axis 1. So I just type AX and click to control and space. Also CODESYS show me that the possibilities. So here is axis 1. And enable is for function block. So I don't need to control the function block. It can stay true always. But I want to control the power, right? So let's call it my power. And for quick stop, we can use the same my power. So here, see, it's already created. So this is for axis 1. Let's do for the same axis 2. Enable is true. And this is, let's use the same input for each. So I don't need to enable one by one. Okay, for the third one, I will just simply copy this one and paste and change the name to 3. I already defined the 3, so yeah, it won't be an issue. I just need to change the axis name, and same input is fine for me. So yeah, power is ready simply. So this 3 function block will work when I enable my power, and 3 of them will be on immediately. Okay, so it was the first. Next thing, let's control the velocity first. Then we will control the position as well. So in order to control the velocity, I already know the function block, but let's see what we can find. So we want to control velocity, right? So this is the keyword for us. So when I click over here, velocity, so here I can see the function blocks that included the name of the velocity. Move velocity here, for instance. We can use this one. And MC move velocity, let's call it 1 again. And let me define name for the other 3 axes. Okay, so this is 2 and this is 3. Again, let's go to help. So I click F1 on keyboard. Yes, and here is the example and the explanation. So first is the axis name again, like MC power, and then execute, start the execution. And then velocity, target velocity, acceleration, deceleration. Acceleration and deceleration is the, as you see, the unit is unit per second square, so it is not millisecond or nothing, no, not like VFT. Deceleration is here, jog is also here. So direction, you can also set the direction, and buffer mode, right now it's only aborting. So yeah, this is the input and output. So let's use it. So axis is 1, execute is start velocity, let's say, and define for me. And the velocity is, yeah, let's call velocity 1, let's say. And type is integer, right? And will be equal to, yeah, let's start slow. And then let me type it here, velocity. Yeah, I made a typo. Yes, okay, so I came here. Yeah, velocity 1. What I did, I created a variable called velocity 1, and data type is integer. And let me show over here. So the initialization number is 360. So first, 360 will assign this variable. Then I can change if I like. So yeah, just for initial value. And same for acceleration. Acceleration 1, let's say, and type is integer and will equal to, yes. What else? Yeah, we can use this one for acceleration 1. For deceleration, we can use the same value. For, yeah, if you don't define anything, there are default values inside. So it uses directly the default values. So I'll just keep them in default. So yeah, let's do the same for other 2 axes. 2 and move velocity 2. And same 3. I already defined them, so that's why there is no warning. And the axis also 3. So yeah, when enable the start val input, then the axis will start to run in this velocity and this acceleration, deceleration value. Okay, so first empty power, then started to run, and we also need something to stop, right? So let's use MC stop. MC stop. Yeah, let's call it 1 again. And this is axis 1. And my stop, let's call just a unique name. And deceleration, yeah, we can use the same value like acceleration 1. And torque is default is fine. And yeah, MC stop 1 is created here. So I will create for 2 and 3. 2 and 3, okay. So copy this one. And over here, let's call it axis 2 and MC stop 2. And same for the axis 3. and MC stop 3. Okay, so let's execute, sorry, build if there is any error. Yeah, so over here there are no any error. A warning is okay, so it can execute, can work, but just for check you can have a look. Okay, never mind. Yeah, so program is ready. Let's download. So go to login and login with download. Yes, almost there. Yeah, we downloaded, and again the stop mode. So I set it on. So these are green and waiting for the access ready. Yes, this is also ready. Okay, so let's start with MC power. Yeah, we said that we can control the MC power with variable my power, and it is for all of 3. So I just simply well, this is easy. So here you can see, you can control directly over here. So you can see the prepared value. So when you change it directly, it will not affect. So you have to write it down. So you can use directly the variable section over here, or there is a watch table inside the controller. How to enable watch table? Inside the view, there is a watch here. There are 4 different tables. So for instance, watch 2 is enabled right now. So simply I can get this one. And then, yeah, you can just copy and drag and drop over here. So yeah, it is prepared value is true right now. So I just right click and write value. So I guess you hear the sound. So right now, let me see, 3 of them is okay. Yes, 3 of them is on. So we can also see the output of the MC power. So over here you can see, or you can simply again come to the watch tab and start with the name of the program. So name of the program is motion and dot. When you put the dot, you will see that the possibilities that you can monitor. So what we want to monitor, we want to monitor MC power, for instance, right? MC power 1, let's say. I click OK and then put that. So here I can monitor all the input and output of the function blocks. So it is same for output. You don't need to define the name, a specific variable for output. So you just simply use the name of the function block and that the output of the function block. For instance, yeah, it is right now status is true and regulator is true. So here you can see status, let's see. Yeah, so it is on right now. And how about velocity? So it's already defined, velocity 1. So motion dot velocity 1, 360. And here, let me add motion dot start well. Yeah. Okay, when I enabled this one, so I click to prepared value, see, but it will not affect till I write. So how do I write? Right click and write value. So right now it is moving. Yes, it is moving. Let me show you as well. Yes. Yeah, here you can see it is moving slowly. This one is moving so slow. I guess we put 1 0 more. We will check the axis setting, but it is moving. Okay, so what we have done, we say that, okay, run in 360. So yeah, one turn is 3600. So we are just moving with 360. So let's change the speed. Let me share my screen again, so you will see. Okay. Let's change this value. So what's gonna happen? In 1 second, it will turn 1. First, I need to disable this one. Control F7, and then I need to stop, right? Let me add here so you will see. Motion.mc, what we set, my stop. So prepare to use F7. So 3 of them stop now. Okay, I changed the speed, so I will again enable the start valve. Yes, right now it is moving. Yeah, so here you can see this is the motor, and in 1 second it turned 1, and here also you can see that in 1 second it turns 1. This is going slow. I guess we did something wrong in the axis setting. We will check this one. But yeah, so here you can see we can control, and let me stop it. Yes, also with the deceleration we assign, it stop. Any questions so far? Okay, I guess hopefully it is clear enough. So another way to control the movement in the software is that monitoring the variable, because it is always communicating via Ethercat, so you can get value from servo drive as well. So right now for me it is easy to see observed by eyes, but you can also control inside the program. How? So you need to monitor the axis. So here I type axis 1 dot. There are many variables I need to remember. I guess some of them. Yeah, F. It starts with F, I guess. We'll see. So here there should be a velocity. Sorry. Or what we can do, simply we can do that. Okay, axis 1. I just add axis 1, and here when I add axis 1, and I can see all the variables inside axis 1. So here this is the F set actual velocity, yeah, and the set velocity. So here I can also see it. Right now it is 0. So when I enable F set value and actual value, let's add these two only. So after find the name, I will add only F set value, F set velocity, and axis 1 dot F actual velocity. Right now we are controlling speed, velocity, so that's why we will monitor these two. Okay, so let me make it run. Motion start valve is 7. Yeah, right now stop is coming too. So both coming at the same time, and yeah, MC stop is executing last. So yeah, so in each cycle actually it is enabling and disabling. So that's why we cannot see right now. So first I need to disable MC stop and then enable this one. So see here you can see the value. So set velocity, actual velocity. So actual velocity comes from the servo drive directly. So here also you can monitor the feedback signal from the servo as well. So this is the way that you observe again by eyes, but yeah, sometimes for applications, it is not simple to observe them, to see like this, it is going fast. So what you need to do, you need to use trend graph. What is trend graph? Trend graph is the part that you monitor the variables Here it's called trace, sorry. So again, it is object. So I'm just going there and adding trace. Okay, and double click. And here, when I double click to trace, here there is a add variable and configuration. So inside the configuration, asking you that you want to trigger it by yourself in the project, or just run with the main task. So I just say that, okay, run with main task. So in each 20 millisecond, if you remember, our task time was the 20 millisecond. So each 20 millisecond, it will go and bring the value. And I will also not use the trigger. So it's already enabled. And yes, this is done. And how about variable? Yeah, here we need to add the variable. So what is the variable for us, for instance? So this is axis one dot f actual velocity. Yeah, this one is the blue. Okay, color is blue, no problem. And add another one, and this is the green. And axis one dot f set velocity, right? So, and it is green. So here you can see actual velocity and the set velocity. Okay, so right click and download the trace. Yeah, there is a big waving over here. Stop trace to see the movement. Yeah, over here you can see that the value is more or less between 3,000 something to 3,700 something. So yeah, so right now there is no auto tuning or nothing. So there is a big vibration over here. But the idea is here that you can simply monitor the feedback value with the trend graph inside the software as well. Okay, so how I did, so I just come it to object, trace, and I set the configuration first, and then add the variable, and then monitor the velocity. Okay, what else? So it was the velocity control, and we also set MC stop. So let me add MC stop too. Yeah. Okay, we say that we did something wrong on one of the axes. So let's check axis setting again. So we said that scaling is 1, 2, 3, 4. Yes, this is true. 1, 2, 3, 4. This is true. Yeah. Okay, here. Okay, we made a wrong conversion, so that's why it was going so slow. So I will just build and download it. Okay, when I'm downloading, for sure servers are power on, off. Sorry. Okay, it is downloaded, so access settings is okay. So I just need to reset them. Yeah. Okay. So everything is ready. So we have done the move velocity, how to control the velocity. So with the MC move velocity, and I will also show the position control as a last, and it will be the last example for today. Let's keep this one. Simply keep this one. So add a new one, low. Okay, so what we need a velocity, no, position control, right? So I came here. So if I write position, let's see if there is something related. No, then move, MC move relative and MC move absolute. So we have two different, actually also additive, but yeah, something different. So there are two main position control function blocks. for IEC 61131, absolute and relative. So absolute position is absolute movement. So you need to make homing setting first, then axis know where it is, then it goes to that position only. But MC move velocity, it is just going when you enable it. So yeah, let's start. Let's use MC move relative. So same principle, asking for a variable. So this is how it looks like. Again, more or less same. Axis name, which axis you want to control, and condition to execute function block. Distance, velocity, acceleration, deceleration. So different from the move velocity, there is a distance. So as you see, MC function blocks, motion blocks are quite simple. I mean, handy to use. So let's define axis 1, and the condition is my post, let's say my position, and it is Boolean, yes. And distance, yeah, again, like we did before, position 1 is integer, and the initial value is, let's make it 1 turn. So this is 1 turn, right? So this is the value we defined. Okay, so here then I need to assign position 1, and velocity can be same. So velocity 1 we set. Acceleration can be same. Acceleration can be same. Okay, so we need to do same settings for axis 2 and move relative 2, and last axis 3 and move MC move relative 3. I guess it is clear that we need to define unique name for each function block because it allows us to reach all the input and output belongs to this function block. Okay, so yeah, it is done. So let's download it. Log in with download. Okay, there are some errors. Let's see. Start well not defined. Oh, we made something wrong. Let's see. Yeah. Okay. Here I forgot this one. Yeah. Position 1, integer. Yes. Right now should be okay. So yeah. Also, development side guide you where is the error. So it helps you for debugging. So login with download. Okay, so make it run. It was stopped, so it is running right now. And let's wait for axis ready. Okay, so right now, yeah, it is ready right now. So let's start with MC power again. So over here, MC power, it's my power, yes. Yeah, you can hear the voice. Also, move relative, let's add my post. Yeah, I add my post too. And let's add, instead of set velocity and actual velocity, let's monitor the position this time. Axis 1 dot F actual position. Axis 1 dot F set position. Okay, here you can see that position is quite far from the 0. Okay, so let's start positioning. So I just right click and write values. So it is moving right now. So see, set value is increasing. Also the actual position is following that one. So right now the speed is quite low. The speed is right now is velocity 1 is 360. Okay, let me show camera as well. Yeah, here you can see the axis. Yes, it is going slowly, so I will increase the speed. Yeah, so I can control the distance, I can control the velocity. It is just a variable that we used inside the function block. Yeah, okay. So yeah, it is simply CFC. I just prefer this one. Actually, for the real application, it's not handy to use CFC language because not easy to make some condition or etc. But the good part is that CODESYS is object-oriented programming, so it allows you to use different functionalities. So, for instance, here you have a ST language over here, right? So under the ST language, you can create a action or method or property. So these are object-oriented tools, let's say. So, and CODESYS allows you to program motion control with object-oriented. So you can also use ST language for machine state control. And for the motion, you can use CFC, for instance. So, for instance, for the MC power, when it is needed, you will call, otherwise you will not call, etc. What else? So we talk about the trace, we talk about how to download, build, rebuild, and for sure for the debugging there is a tool like like any other PLC programming. And we talk about the tools. Yes, that's all from my side. If you have any questions, I would like to listen.